video, we're going to have a look at how matrices can be used to solve simultaneous equations. We'll do so by means of this question here. So, part 1 of this question, find the inverse of that matrix there. Well, first of all, the determinant of that matrix, 4, 3, minus 1, 2, is simply 4 times 2, multiply the leading diagonal, minus the product of the other diagonal, 3 lots of minus 1, equals 8 plus 3, which is 11. So the determinant's 11. We learned in a previous video that the inverse of a matrix was simply 1 over the determinant. And you can have a look at my proof of this in our previous video. And what we do, we swap the position of the items in the leading diagonal, 2 and 4 there, and we flip the signs of the other two, so that becomes minus 3 and that becomes 1. So there's the inverse. Part 2, use this inverse to solve the simultaneous equations 4x minus y equals 49 and 3x plus 2y equals 100. So this here, this can be used to make a matrix equation. So we've got that there. We're going to try and formulate those simultaneous equations in matrices. So the first column is going to be my x coefficients, 4, 3. And the second column is going to be my y coefficients, minus y and 2. And I'm going to propose that if we multiply that by xy, we get those simultaneous equations. So if we multiply this matrix out, we get 4x, take 1y, and here we get 3x plus 2y, exactly the left-hand side of these simultaneous equations here. So that must be equal to 49, 100. So again, just checking, and you don't need to do this in an exam. Anything in blue is part of my exam answer. Anything in red I'm going to do is just explanation. If I multiply that out, 4x minus 1y equals 49. Put that back. And 3x plus 2y equals 100. So we've written those simultaneous equations in matrix form. So looking back at the original question, we can see that this particular matrix, 4, 3, minus 1, 2, is actually called M. So we could rewrite this if we wanted to as M times a vector xy equals 49, 100. So now the next step is to think, right, how do I get what x and y are? How do I get xy on its own? Because matrix division doesn't exist. We can't divide by matrices. Well, actually, if we times on the left by the inverse of m, both sides, so m to the minus 1 m of xy equals m to the minus 1 of 49, 100. Now, it's so important that you multiply both on the left, because matrices aren't commutative. You can't multiply one on the left and one on the right and still maintain that both sides are equal. You've got to decide whether you're going to multiply both sides on the left or on the right. Now, the reason I multiplied on the left is because I wanted this to happen here. I wanted a matrix to be touching its inverse, because when a matrix is multiplied by its inverse, we just get the identity matrix, i.e. nothing happens. So now we've got an expression saying xy equals, and that's what we wanted, xy equals the inverse of m times 49 over 100. Well, actually, we've got the inverse of m from a previous part. It's an 11th, 2 minus 3, 1, 4. You can see that there. So, multiplying that out, we get an 11th, 2 minus 3, 1, 4, times 49, 100, equals, okay, well, we'll keep the 11th at the front for now. We'll do the 11th later. So 2 lots of 49 plus 100. So using the calculator, 2 lots of 49 plus 100, which is 198. So 198 on top, then minus 3 times 49, plus 4 times 100. So minus 3 times 49 plus 4 times 100 equals 253 on the bottom. So 253 on the bottom. That means that xy equals, so 11th of that. So 198 divided by 11, 198 divided by 11 equals 18, and 253 divided by 11 equals 23. So being completely specific now, therefore x equals 18, y equals 23. And that's how you use matrix methods to solve simultaneous equations. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to A-levelmathsrevision.com.